All right, today we're going to look at solving equations of multiple trig functions or arguments. So not just like sine of x, maybe sine of 3x, or maybe there's a sine squared and a sine, etc. in our function. So let's look at the first one. The first one says, okay, we've got the equation 3 sine cubed equals 2 sine squared. So in this case, I would always say, hey, let's set it equal to 0. So if I do 3 sine cubed of x minus sine squared of x equals 0. You can almost think about these like factoring problems. So take out what they have in common. They both have a sine squared of x in common. So we're left with 3 sine of x minus 1 equals 0. Okay, think back to what we did with factoring, or what you have done with factoring. You set both of these equal to 0 if the whole equation is equal to 0. So if sine squared x equals 0, it doesn't matter what you multiply it by, it will still equal 0, and vice versa with 3 sine of x equals 1. So now, think about solving these two individual equations. Let's take the square root of both sides. We get sine of x equals 0. We don't have to worry about plus or minus, because 0 is neither positive or negative, so then you just ask yourself, okay, well, when is sine of x 0? And sine of x is 0 at 0, but it's also at pi, so I'm going to do plus pi k. Okay, for this one, let's start getting sine of x all alone. So we're going to keep the 3, but add the 1 to the other side. And then we'll divide by 3. So now, how do you solve that? Well, remember we do our arc sine, so x equals arc sine of a third. You gotta be a little careful here. So the sine is positive in the first and second quadrant. So this time I am going to do every 2 pi k. But I've got to represent something in the second quadrant as well. So I take pi and I subtract my arc sine of a third. I'll be in the second quadrant, but then it repeats every 2 pi k. So my exact answers are these ones down here, right? But then it always asks for the answers in the interval 0 to 2 pi as well. So therefore, if I think about 0, I'd be at 0. I could also be at pi, and then I'd be at arc sine of a third, and pi minus arc sine of a third as your exact answers in that interval. All right, as we take a look at the next one, we're now doing something that has multiple trig functions. So notice this has both tangent and secant. With these ones, you should usually either like notice a relationship or be able to kind of substitute something and like rewrite it in terms of sine and cosine. So let's dive in and take a look. So tangent, we know, is equal to 1 minus secant. Or sorry, not 1 minus secant. Let's write this over here. So if you ever get confused about that, I'm going to do a little side note. I'll do it over on this one. So let's see what we remember. Sine squared of x plus cosine squared of x. We know the Pythagorean theorem identity. And if I want tangent, I'm going to divide everything by cosine squared of x. So we get tangent squared of x plus 1 equals secant squared. So think about subtracting 1 from both sides. So here I can rewrite tangent as secant squared x minus 1 equals 1 minus secant of x. Okay, now ask yourself, okay, well, how do I solve this equation? Think similarly to what we've done before, where we are going to subtract the 1 and then add secant to the other side. Subtract 1, add secant. So we'd be left with secant squared of x plus secant x equals 0. Once again, when we got this quadratic, we're thinking about a factoring. So take out a secant, I'm left with secant x plus 1 equals 0. So either secant x equals 0 or secant x plus 1 equals 0. I lied. let's go back for a second, sorry. I got a little distracted there. So when we subtract 1 from both sides, we don't actually get 0, we get a negative 2. So therefore, we're saying what multiplies to negative 2 but adds to 1. So we've got a positive 2 and a negative 1. And rather than having x here, we've got secant of x. These are really like the u substitution we did in 1050, but I think if I actually put u substitution, you may hate me a little bit, so you can think about secant, etc. as being your variable x. Okay, so let's take a look now at these two solutions. So this one we get secant of x equals negative 2. If I move it to the other side, and this one I get secant of x, and add 1 to the other side equals positive 1. Okay, secant is 1 over cosine. So think about like negative 2 is going to come from the half being flipped, and then cosine is negative in the second and third quadrant. So here we've got our reference angle of pi thirds. So we're going to be at pi minus pi thirds, which is 2 pi thirds plus 2 pi k. And we're also going to be in the third quadrant, which is 4 pi thirds plus 2 pi k. As we think about this other one, when is secant equal to 1? So the place we get that is at 0. So x equals 0, and it is plus every pi k that repeats. Actually, wait, for a positive one, it's going to repeat every 2 pi, right? So now x equals, okay, I guess that's just, and there's no other place that it equals a positive one. So these are my exact solutions, all my exact solutions. And then in the interval, if I look at this first one, I get 2 pi thirds, and there's nothing else from 0 to 2 pi. I get 4 pi thirds, and then I get 0. Okay, let's look at the next one. This one, you have multiple arguments, but at the same function. So notice we have all cosine, but I've got like a cosine of 2x, and I also have 5 cosine of x. I would think about rewriting this cosine of 2x some other way that we know it. So over here, I could maybe think about, let's use the purple. I could think about, hey, cosine of 2x equals cosine squared of x minus sine squared of x. So remember, there's some equivalent forms. If I replace, in this case, we probably want to leave it in terms of cosine because we've got that other cosine. So if I replace sine squared of x with 1 minus cosine squared of x, I'm going to end up with 2 cosine squared of x minus 1. So I'm going to write our equation as 2 cosine squared of x minus 1 equals 2 minus 5 cosine of x. So let's move this 2 to the other side and add the 5 cosine of x. So we get it equal to 0. Once again, we're thinking about a factoring problem. So 2 cosine squared of x plus 5 cosine of x minus 3 equals 0. Okay, this one is a little bit harder of a factoring problem, but you take the 2 and the negative 3 and you say, okay, we multiply those together, we get negative 6. So it multiplies to negative 6 and adds to 5. We get 6 and a negative 1. So then we rewrite that middle term of 5 cosine x as plus 6 cosine x minus cosine x minus 3. And then remember we do our grouping. So the GCF of this first one is cosine of x. So we're left with cosine x plus 3. The GCF of these next ones is negative 1, so we get cosine x plus 3 equals 0. We get 2 cosine x minus 1. Cosine x plus 3 equals 0. So if you think about setting this first factor equal to 0, I'm going to add the 1 and then divide by 2, so I get cosine of x equals a half. On this one, we're going to get cosine of x equals negative 3. Okay, so cosine of x equals a half. Cosine is a half when x equals pi thirds. And then that's plus 2 pi k. But it's also positive in the fourth quadrant, so I'm going to just call it negative pi thirds plus 2 pi k. If you prefer, though, that's the same as 5 pi sixths. Okay, this answer over here, though, cosine of x equals -3, that's never going to be true. So I'm going to ignore that solution because it's extraneous. So we end up with just those two as our exact answers. And if I start plugging things in, I would just have pi thirds. Negative pi thirds is not my interval, so I'm going to have to add that to pi and actually write it as 5 pi thirds here as my answer.